Hello, and welcome to my presentation on conformers in organic chemistry. I've been given a specific compound, compound Z, and I'm going to have a look at all of the conformers and even then plot the relative energies of those conformers relative to each other. Okay, so here's compound Z. First of all, I need to name it before I can do anything else. So the first thing when you're naming an organic compound is to look at the longest carbon chain. Here, I'm circling the carbons with the long part of the longest chain. There's only 4. This 5th carbon up the top here is going to be my methyl group, but the other 4 are part of the longest chain. 4 carbons is a bute, therefore its prefix, main name is bute. Next we look at any non-carbon groups that are joined to it, anything like a nitrogen or a sulfur or an oxygen, anything like that isn't present right now. It's purely just carbons bonded to hydrogens and carbons, and all of the bonds are single bonds, no double or triple bonds, therefore it's an ane. When next we need to do is consider the methyl group. Here I've labelled each of the carbons 1 to 4, and the methyl group occupies the 2nd carbon, therefore it is 2-methyl. However, the 2 is irrelevant in this case, because if the methyl group was on carbons 1 or 4, it would just be a pentane, so it's not what we're looking for. And the methyl group being moved to here, carbon 3, makes no difference either, because that would just be a rotation 180 degrees of the molecule. Therefore the 2 goes away, and we can put the name together and get methyl butane. Okay, so now that we've named our molecule, we can look at the Newman conformations. And here is my 0-degree conformer. I've got a little table in the top left, my key here, just to show which carbons are which. These are the main carbons I'm considering. Obviously the C to C to C to C bond, the dihedral angle. I'm going to be rotating this middle bond here that I've circled. So this carbon is, say, carbon 1, and then the carbon on the very end is either carbon 2 or 3, either one. I will be considering and looking at the relation between 1 and 2 and 1 and 3. So this is the first one, as I said. The main thing to note here is that carbon 2 is eclipsing carbon 3, and that's pretty much it. Next, when we rotate the bond with respect to the 2nd carbon, this one here, we can rotate it 60 degrees clockwise, and we get this conformer. The main thing to note here is, first of all, carbons 1 and 2 have some gauche interaction between each other. They've got a little bit of repulsion now. It's worse repulsion than you get in the first conformer for sure. However, the fact that this is a staggered conformation rather than eclipsed on the left makes it slightly better, more favourable. And the carbon 1 and carbon 3 are anti-paraplanar, to each other. So that's quite good. That's quite low energy. It's good for that to be that way because methyl groups want to be as far apart from each other as they can. Rotating again 60 degrees clockwise, we get the opposed structure. So here, either all of the methyls are being either eclipsed in this case or eclipsing in these two cases a hydrogen atom. This is, while looking quite favourable for the molecule to be, it isn't that good because this is eclipsed. I'll explain that in further detail when I go to the graph. But rotating again, nevertheless, 60 degrees, we get this 4th conformer. The arrangement of it is almost identical to the 2nd conformer, other than the fact that carbon 1 and carbon 2 are now anti-paraplanar rather than carbons 1 and 3, where carbons 1 and 3 are now in a gauche between each other. Rotating again 60 degrees, we get the same as the first conformer, where a methyl group is eclipsing another methyl group. This time carbon 3 is eclipsing carbon 1. And the last rotation we do, 60 degrees again, the very final conformer we get is this one in the bottom right corner, where there are 2 gauche interactions between carbons 1 and 2 and carbons 1 and 3. Okay, so now that I've done all the Newman projections, we can plot them out on a graph and compare them to each other. So the graph here is already drawn out, and I'm just going to go through each of the peaks and troughs and organize the Newman projections in the relative area. So obviously the way they rotate is going to relate to their location on the graph. The 0 degree dihedral angle, the very first one we looked at, is going to be very high energy, mostly due to the fact that the methyl groups being eclipsed is a bad thing. It's a very high energy state. The methyl groups are very large groups, and so when they are eclipsed by one another, it takes up a lot of room and puts them very close to each other, and they don't want to be like that. They want to be far apart. So the repulsion experiencing of these two methyls affects the whole molecule and increases the energy of the conformer. Next, when we rotate to the second conformer I had, it's our 0 energy. This is 0 kilojoules per mole relative to the first conformer. This isn't 0 at all. If you were to measure the energy of this conformer, it would not be 0. Just as a point to say, mostly because of the fact that this gauche conformation here, while, like I say, is better than being eclipsed rather, the gauche is still unfavorable, with carbons 1 and 3 being anti-paraplanar to one another being good. So that's mainly the reason why it's our lowest energy one. Rotating again the 60 degrees and we get the all opposed one. So this is where the main law of conformers, that a staggered conformer is always lower energy than an eclipsed conformer, S being staggered, E being eclipsed. Staggered, always lower energy than eclipsed, as far as we can do in this molecule. So that's first of all an easy way of knowing that when you start with an eclipsed conformer, you will always, the next rotation by 60 degrees will make a staggered, and then eclipsed, and then staggered forever on and ever on. So it follows that because of this, if we have a staggered conformer, the next conformer, the eclipsed one, is going to be at least very slightly, if not much, much higher energy than the one that we just went from. So even though all of these methyl groups are being eclipsed or eclipsing a hydrogen, it doesn't make a difference. It's eclipsed, therefore high energy, although it's not as high as the first conformer. The next rotation was the exact same thing as the second conformer, so not too much to worry about here. It's just going to be the exact same energy. And again, repeat of the last point, the conformer 1 is identical almost entirely to conformer 5. It's identical in terms of energy, just obviously the different carbons, but all methyl groups are the exact same as each other, so it's basically the exact same thing. The last conformer that we go to look at, conformer 6, has a slight dip just before going back up again. So this one here is exactly the same as this one here. Obviously, that's why the labels are the same. It's just the whole point of the latter part of this curve is just to show the fact that you go from here, the energy is increasing again. But to consider the sixth conformer, even though we see here the two gauche interactions between these methyls, while as we know gauche is unfavorable for methyl groups, the fact that staggered, which is what conformer 6 is, versus the eclipsed, which is say this conformer 3 is, conformer 6 is still lower energy than conformer 3. If I just extend this line out here, not very well, but you can still see that this is going to be lower energy, because it is definitely lower energy due to the staggered being lower energy than eclipsed law. So one thing to note though, just as a side, is that gauche isn't always a problem. In here it's definitely a problem. If you have, say, an oxygen, an OH, bonded to a carbon, and then from another side of the molecule you have the same thing again, a carbon attached to an oxygen attached to a hydrogen, I don't know, just say there's a C in between there. The hydrogen bonding here of the gauche would allow a much more stable molecule. However, in the case of the methyl butane that we're looking at, the gauche interaction would cause the methyls to be slightly further apart from each other. They'd slightly repel because they're too close to each other. They don't want to be here. This the carbon number 1 wants to be as far apart away from the methyls as it can, which is why this number 6 is not as high, or isn't as low, as lower energy as the 0 conformers here. These ones are 0 only relative to the first conformer, as we said before. So number 6 relative to number 1 is still fairly low energy, but it's still got some repulsion there. More repulsion, in fact, than the 0 energy conformers.